Okay, in today's lesson, I'm going to teach you about a different type of graph. But before I do that, it's going to be your job. So kind of think about the riddles and how you had to find different patterns in those riddles that I gave us. You're going to kind of be looking at the same thing. So you should notice there are 6 problems here. Each problem has an equation, a table, and a graph. And I've already worked all of that out for you, so you don't have to do that part. But what I want you to do is compare the problems to one another and see if you notice anything, any patterns. So you should notice that some of these look a little bit different if you look at the graphs. So based on that, could you look at the equations and figure out maybe what's different? Or maybe see if you find any patterns in the tables themselves. See if you notice anything that's happening in the tables. You may also find some relationships between the equations themselves and the tables that match them. So you may want to compare the equations to the tables. But you do need to probably pause the video, I would say for maybe about 5 minutes, 3 to 5 minutes, and see if you can find 5 patterns. You're about to have an Edpuzzle question on which patterns you find. Also, you do not need to worry about copying any of this down. I will have a copy of this page for our notes when we come back to school on Monday. So you just need to make sure that you are trying to find some patterns. So this is the only real page of notes that you're going to need to take today. This is the only slide. We need to title it Quadratic Functions and Parabolas. So a quadratic function is anything that has x squared in it. So this right here is what makes something a quadratic function. Quadratic function. And when you graph quadratic functions, you get a shape. It looks kind of like a U. It's a shape that's called a parabola, which is kind of a weird word. And most people, when they read that word the first time, they try to say parabola. It is parabola. All right, now you do need to make sure you have this graph copied in your notes because I'm going to show you, I think there's going to be 4 different parts of the parabola that are very important, and this vocabulary you're going to have to know going forward. So the first part of the parabola, I don't know if you noticed, well, first of all, it's a U shape, so that should have been maybe one of the things you observed from the previous question, that anytime you have x squared, it causes a U shape in the graph. And I don't know if you noticed it in the table, but you should have seen, hopefully, that the tables kind of had mirror numbers. So like it would count up to a certain number and then start counting back down again. Or maybe the other way around. Maybe it would count down to a number and then turn around and count back up again. That is because of this line right here. And I draw it as a dashed line because it's not really part of the graph, but it is, it is part of the graph, but not something that you draw as part of a solution. This line is called the axis of symmetry. And symmetry just makes, it should kind of make you see or notice that this parabola can be folded in half, right? There's always a mirror number on the other side. So like this point at the top, there's a mirror number on the left side. This point on the left, there's a mirror number on the right side, right? Each point has a mirror image on either side of the line, and that line is called the axis of symmetry. You should probably put a note to yourself that this is always an x equals line. All right, some other points that we need to find. There's a point down here. You may have noticed, like I said in that table, that there was kind of a turning point, and this turning point is called the vertex. So the vertex is going to either be your lowest or your highest point, but it's your turning point on any parabola. These other points you should be familiar with. Remember, any place that a graph crosses on the y-axis is called a y-intercept. And we're going to see where that ties in. You may have noticed, but that actually ties in to the equation itself. So look at your equation and see if you can find where that y-intercept is coming from. And hopefully you notice it's coming from this last number here, the one that doesn't have any variables with it. That is the same as the y-intercept. Okay, the very last piece of information that we see on the graph is going to be these 2 points right here. And again, those are on the x-axis, so those are going to be x-intercepts, but they actually have 4 different names. We need to make sure we know all of them, because on tests and in multiple choice questions, you're going to see them in all of these different formats. So these are called x-intercepts, but they can also be called solutions, roots. So don't think square roots, but they're called roots, or zeros. And I know those are kind of some strange terms to group together, but all 4 of those are the same thing. They mean where the parabola is going to cross the x-axis. So you need to know all 4 of these pieces of information. And then the last little part that you're going to need to know moving forward, and we're going to spend some time on this next little piece of information. Everything so far has just been definitions, so there shouldn't be anything that you don't understand, because it's just definitions that you need to know. The next part, though, you may have a little bit of trouble following, maybe not, but if you do, that's okay. You just need to let me know that so that we can spend a little bit of time together going over this stuff in class. So domain, we've learned this before, and you need to probably write it down. Domain are your x values. And see, parabolas, if you look at the top of this parabola, it has arrows indicating that it's going to go up and actually out forever. So, for instance, this is going to go like to the left forever and to the right forever. Well, that means my domain values are going to be all real numbers. And that will always be true of a parabola. The domain will always be all real numbers unless we're doing word problems. All right, my range is going to be a little different though. My range are my y values. And if you notice here, it goes up forever, but on my range, it does not go down forever. Like normally a line is going to go up and down forever, but on my range, it looks like the lowest point, the lowest y value that I ever get on this graph is -4. That means my range is going to be y greater than or equal to, because it goes up forever, greater than or equal to -4. All right, so if we need to spend more time on domain and range, that is perfectly fine. But all of these other definitions you need to have in your notes so that you can refer to them as we move forward with our next lesson.